These are the SOIC to DIP adapters I have been using with ATtiny microcontrollers. I have adapters for 8, 14, and 20 pin ATtinys. 2 are designed by IMSAI Guy, who has an excellent YouTube channel, link below. His video tells how to get his adapters. I also bought 2 from Amazon and built one myself. This video is about why I bothered to build my own adapter and how you can get them. All of these adapters work, but there are advantages and disadvantages, such as width. You can see that the Amazon 14-pin adapter is wider and will consume extra columns on a solderless breadboard. This is why IMSAI Guy built his adapters that trade off narrowness for longer trace lengths and some parallel traces. Place for decoupling capacitors. The Amazon adapters and IMSAI Guy's 14-pin adapter are generic. They don't include a decoupling capacitor. You can still solder one between the VDD and ground pins, but this is not as good. I'll show a picture below. My board includes both primary and secondary decoupling caps. But the main reason I made my own 14-pin adapter is that I wanted a narrow adapter like IMSAI Guy's, but I found his boards hard to hand solder. I wanted larger pads so I could get the tip of my soldering iron onto the pad itself. This, with the help of flux, makes it easy to get solder to flow between the pin and the pad. The Amazon adapters have large pads, actually larger than necessary. My board has pads that I think are just right. I think IMSAI Guy used KiCad's standard footprint. This gives pads that are perfectly sized for oven or hot plate soldering, but that's not what I do. I'm not an expert at surface mount soldering. My advice is don't be totally afraid of it. If I can do it, so can you, especially if you stick to larger pitch components. Here's my soldering technique. I use a TS100 soldering iron with a narrow conical tip. I apply flux using a flux pen and apply a little solder to one of the pads. I then use high-quality tweezers to hold the ATtiny in place, and I touch the iron to the pad with the solder. This tacks the ATtiny in place. I then touch the iron onto other pads next to their pins, and I flow solder. The flux sucks the solder between the pads and the pins. Do this for all pins, including the one you used for the initial tacking. I find the key to making this easy is to have pads that are just big enough to allow me to touch the iron to the pad right next to the pin, rather than on the pin itself. The pads on the IMSAI Guy boards are too small to easily allow this. Oversized pads are sometimes called hand soldering pads in component footprint libraries. I also used a large-sized 1206 footprint for the primary decoupling cap. IMSAI Guy used a smaller cap footprint. The cap pads are on the back of IMSAI Guy's 20-pin adapter. His 14-pin adapter has no place for a bypass cap. I don't think lack of a place on the adapter for a bypass cap is a huge problem in this application. You can solder a cap between VDD and ground like this. Primary bypass cap should be as close as possible to the VDD pin, but this is at least as good as what you could do with a dip part on a breadboard. It's not ideal, but it's probably good enough. The ATtiny 3224 datasheet suggests both primary and secondary bypass caps. Here's where they go on my adapter. And here's a picture of the populated boards. I was able to hand solder IMSAI Guy's board, but it was relatively difficult. I built an adapter board, so how does that help you? Well, I'll put the Gerber design files onto my GitHub, link below, and then you can order and build boards for yourself, and I'll show you quickly how to do that. And the company that I use is PCB Way, and I am not sponsored by them. I'm just a satisfied ordinary customer. But anyway, the way you do this is you say quote now, and in a little bit of time, you can go down here and click on Quick Order PCB. And that allows you to upload the Gerber file that I'll put on the GitHub. So I say add Gerber, and build adapt0.zip is the one that I actually built. And so then it inputs that, and it does some thinking about it. It checks it to see that it meets their standards and stuff like that. So that takes a moment. And that's done. And now if I scroll down, you can see a bunch of, complicated choices. But the good news is that taking the defaults is usually a good option for a hobbyist board and is also the cheapest. The one thing that you do want to try is increasing the quantity, because sometimes you can increase the quantity and the price doesn't go up. So in particular, if I pick 25, or if I pick 20, the price remains 5. If I pick 25, the price goes up. So let's go back down to 20. So basically, you're able to order 20 of these boards for $5 plus shipping. And this is DHL, a reputable shipper, and then the shipping costs more than 4 times as much as the board itself, but the total still isn't very high. They do offer some other lower cost shippers that are more sketchy. I have successfully used them twice though, so if it's a low dollar order, you might risk it and use the sketchier, cheapest shipping you can find. And that can bring the cost down to maybe $11 total, something like that. So anyway, that's how you do this. You just have to now save it to your cart and check out. You'll probably need to make an account. But other than that, it's like any normal, e-business. And they'll manufacture the boards and ship them to you. And there are other companies you can use too, but the only one that I've tried is PCB Way. One thing I guess I need to say is that I don't know what effect the current tariffs are going to have on PCB Way. As far as I can tell, they haven't done anything to increase their prices yet, but I don't know what will happen. That's all very confusing. And then also there's an online Gerber viewer. And what that lets you do is check the Gerber files to make sure that PCB Way's tools are happy with them at least a little bit. And so that's a good thing to do. So if you click here, once again, you can pick the Gerber file and it'll show up. And then I need to figure out how to get to the bottom here to do some zooming. Here we go. So zoom out. So now you can see the whole board. Maybe I can zoom in a little more. All right. And then you can, like right now we're looking at the top layer, so you can check it and see if it looks sane, like all of the traces are connected to the pads that you expect. You can do the same thing on the bottom. You can also see the vias and the drill holes and stuff like that. And if you click on layers, you see all of the layers. So it's actually good to take your Gerber and put it into this Gerber viewer and just kind of check it. It will increase the chances that PCB Way will have no trouble building your board. So anyway, if you want to try it, go ahead and build some boards. I'll end this video here. See below for links, and thanks for watching.